Hi, welcome back. So in this video, we are going to continue with adding functions to our supply chain smart contract. We've added a few, we've added 4 functions actually so far. We have 4 more functions to add. But before we start adding those 4 functions, there are 2 pieces of code I want to add before we proceed. So the first one is an event because we are going to use it in other functions that we are going to create. So I'll create an event, and the second one will be a modifier. So after creating the event, I'm going to talk about what an event is and what a modifier is. So let's create an event called transfer ownership, and transfer ownership is going to take a uint 32 product ID. So this is an event. So what an event is we use event to communicate back to client applications if something happens. So in our case, we're going to use it in our new function to emit that an ownership was successfully transferred, and we'll pass the product ID. Okay, so the next thing I'll create is a modifier. Yeah, so we've implemented something like a modifier. We've used the require statement before in our application, and a modifier, it's a better way to implement like what a require does. After typing it, I'm going to explain. Okay. Modifier looks like a function when declaring it, because it also takes parameters, and so this modifier requires that message.sender is equal to the product owner. So we're going to use it in our next function to specify that anybody who's calling that function will have to pass this require statement. So it requires that message.sender is equal to the product's owner. Yeah, this command will enable the flow to continue after this becomes true. So we have been able to create these 2. We needed this in our next function. We're going to use these functionalities. Okay, so that's why we needed to declare them now. So the next function we are going to create is kind of tricky. I'll do my best to explain them very, very well. Okay. It's a lengthy function called new owner. Okay, and seems like it's doing a lot here, but I'll try to explain. So new owner takes the following parameters: user ID, user ID2, and a product ID. So what new owner does is that when moving a product from one state to another, it exchanges who the owner of that product is. The owner of the product who created it might not be the owner at some point, because it might have been gotten by another owner. So what we are doing with this function is to, in our supply chain smart contract, to be able to change a product owner from one owner to another owner. So it takes the following parameters: a user ID. So we have from one, since we're transferring ownership from one owner to another owner, it's going to take two user ID. One is going to be the ID of maybe, let's say, the previous owner, and the other one is going to be the ID of the new owner. So we're using user 1 and user 2, and the product that we want to change. So now, as you can see over here, we are using the only owner modifier that we created before this function. And as you can see, the only owner takes a particular ID. So what this means is that anybody that wants to call this function needs to be the owner. So if we take a look at the only owner modifier, we'll see the require statement. We'll see the require statement that makes sure the message.sender is equal to the product owner. So that's what the modifier does. It fires a require statement that must be passed before this function can be implemented, and it returns a bool to show if it's successful. So if we move into the function, as you can see over here, we are declaring two memory variables called P1 and P2, and we are assigning user ID 1 and user ID 2 to P1 and P2. Let's say participant 1 and participant 2. And in the next line, which is line 95, we are incrementing an owner ID, meaning like we are trying to change ownership. So that needs to have an ID and to keep track. So we increment the ID. And what is happening here in line 97 is that we are trying to compare that, we're trying to do comparison here. We've done this before in one of our functions where, like I said, you can't compare strings, you have to hash them. So that's why we're using the KCAC 256 hashing to hash a participant ID and compare it to manufacturer. So what we're doing here is that we are comparing a participant type to manufacturer to make sure that whoever is, if the person calling this function, it's a manufacturer. We're also using an AND statement, meaning both what's on the left and on the right of the AND statements must become true in order to progress into the function. So we are making sure participant type is equal to manufacturer and participant type 2 is equal to supplier. So we want to make sure that whoever can participate in the implementation of this function needs to be a supplier. P2 needs to be a supplier and P1 needs to be like a manufacturer. So that's what this if statement is doing here. If we validate that both participant type 1 it's equal to manufacturer and participant type 2 it's equal to supplier, then we now proceed into the implementation. And what we are basically doing here is that we are creating a new owner. So we are passing the new owner product ID to the ownership's struct. And you know the ownership struct has different attributes: product ID, product owner, owner ID, transaction timestamps, and all that. So we are passing this new product owner's attributes to the ownership mapping. So we pass the product ID, the participant ID. So we are over here, we are setting the new participant ID. okay, which is the P2 as the product owner in the struct. Then we also set the user ID to the new user ID, like the participant 2 user ID, okay, and the timestamp and the address of the new participant or the new owner. Then we append, using the push, we append the ownership ID to the product ID. Then this is where we emit the event that we created during the start of this video. We emit that event, which is the event's name is transfer ownership, and we pass the product ID. So what this means is that if this is successful, it's going to emit, or when we say emit, like it is triggering the transfer ownership event, and that we communicate back to whoever is calling this function that, you know, there's been a change in the of who owns the product with this product ID. Then we also, so we're comparing 3 different instances. The first one is for, we're making manufacturer and supplier. Then the second one is we're comparing participant type of participant 1 to supplier, okay, and we're making sure we're comparing if participant type 1 is a supplier and if participant type 2 is a supplier. Okay, so this is the change of ownership from a supplier to another supplier, and we do basically the same thing by assigning the new values to our struct. We assign the product ID, the participant address. We do the same thing that we did here in the first if statement. Okay, we assign the new values and also emit the transfer ownership event. Then the last comparison is if P1, participant type 1, is equal to supplier, and if participant type 2 is equal to consumer. So this is another instance where whoever is calling this function, one needs to be a supplier and the other needs to be like a consumer. And we also do the same thing by assigning the new values, okay, and also append the new ownership ID. We also emitted the transfer ownership event. Yeah, so this is basically it for this function. We have 2 more functions, or 3 more functions to go. The others are not too lengthy, so I'll paste the first 2 and also explain them. So the first one is get provenance. What this simply, we use this function to get the history or to track a particular product. So we want to know the history of how that product has moved onto a particular stage. So that's what get provenance does. And it takes an ID, it returns an array of uint32. So what this simply does is that it returns the track. Like using this ID, it returns the history of a particular product. Okay. Then the second function is get ownership. We want to know, this helps us to know the ownership of a particular product. Okay, and it takes a reg ID and it returns these values. It returns a uint, an address, 3 uints and 1 address. What it does is so it goes to, so it returns the product ID, ownership ID, product owner, and transaction timestamp. So that's what this function does. The last function is about authentication. Okay. So this is not like the best way to implement authentication in your application, but we are just using it. It builds like the basics of what happens in authentication. So this is the function called Authenticate Participants, and it takes the following parameters: the user ID of the participant that you want to authenticate, the username, password, and new type. Okay, and it returns a bool if successful. So what it does is that it compares the participant type to U type. It does another comparison of the participant username and another comparison of the participant's password. So once all these statements are met, and if they return true, then the participant is authenticated. Yeah, so this is our supply chain smart contract. As you can see, it has a lot of functions and state variables. So thank you very much for this. The code is on GitHub, and you can implement these projects. So what we are going to do in the next step is to set up our hardhat.config.js file so that we can deploy this application on the RSK testnet. So in the next video, we are going to go through the process of configuring our hardhat config.js file to point to RSK testnet, and before we now deploy this application to the RSK testnet. Thank you very much.